Section 8.2 in some sense is a repeat of Section 8.1 in that every problem is a system of linear equations. It's a system of equations, which means either I have two equations and two unknowns or three equations and three unknowns. I mean, literally, you could have two equations and five unknowns, but for us, our systems of linear equations will be two equations and two unknowns or three equations and three unknowns. And the title of this section is called System of Linear Equations Matrices. And we're going to learn another way to solve systems of equations, essentially using the elimination method, but we're going to use the elimination method in a rework of the problem that has the problem rewritten without the letters. And the nice thing about solving systems of equations using something called a matrice or a matrix is that our calculators can do it really quickly. If I was asked to solve a system of linear equations by hand, I wouldn't use matrices because they're very, very tedious to do systems by hand. But if I'm given a system of linear equations and I'm asked to solve it and I'm just worried about the answer, then I can use technology or my calculator to get the answer. So I should probably lecture for just a brief minute on what a matrix, or the plural of matrix is matrices. So a matrix is just, essentially, it's just a table. And for our purposes, it's going to be a table of numbers. It doesn't have to be numbers. It could have letters. It could have anything in the table. And we can say a matrix can be used to represent a system of linear equations. But not all matrices. That's the plural of matrix, represent systems of linear equations. Let me just write an example of a couple matrices. Usually, matrices are defined with capital letter names, so I'm going to create a matrix. I'm going to call it matrix A, and usually we put a matrix in these kind of rectangular brackets. This particular matrix A, I'm going to say it has two rows. This would be representative row 1. So the top row there is row 1. And that would be representative row 2. So there's the two rows that make up this matrix. This matrix also has 3 columns. And if I want to describe the columns, this would be column 1. This would be column 2. And this would be column 3. Let me make up another example. Here's a matrix B. Matrix B, that I just kind of randomly made up, has 2 rows again. and 5 columns. If I wanted to just say what row 1 is, row 1 is the numbers 1, 2, 4, 5, and 6. I'll call that row 1. And row 2 has the numbers 3, 2, 4, 8, and 9. The columns, column 1 has the numbers 1 and 3 in it. And then column 2, column 3, column 4, and column 5. So I'll write C2 for column 2, C3 for column 3, C4, and C5 for the columns. So matrices are just tables of numbers. These matrices, matrix A and matrix B, don't necessarily represent a system of linear equations. In fact, they probably most definitely don't represent a system of linear equations, specifically because there wasn't a system of linear equations I used to create the matrices. We're going to have the need to enter matrices on our calculator, so let's learn how to do that. Let's learn how to put matrix A as a 2 by 3 matrix in my calculator. Oh, I didn't even say that. So matrix A, because it has 2 rows and 3 columns, we say matrix A is a 2 by 3 matrix. It has 2 rows and 3 columns. Matrix B, because it has 2 rows and 5 columns, we say matrix B is a 2 by 5 matrix. When we go to enter a matrix on our calculator, we need to know how many rows and how many columns it has, and we need to know its dimensions. We say the dimension of matrix A is 2 by 3, the dimension of matrix B is 2 by 5. Real quickly, let me enter these on my calculator. So to do this on my calculator, some very specific steps. The first step to enter matrix A on my calculator is I'm going to hit the, on my calculator, to enter matrix A, the first thing I'm going to hit is the blue second button. And then after I hit the second button, the key that says X inverse, right above it, it says matrix in blue. And when I hit the X inverse, because I've hit the second first, it's going to activate the matrix. And then my calculator brings up a matrix screen. I haven't even hit enter yet. I'm going to arrow over twice and get the edit highlighted. And because I'm going to do matrix A first, I'm going to get in the names column A highlighted. I've entered a bunch of matrices on my calculator. I'm not exactly sure how to delete these matrices from my calculator. It doesn't matter that I have a bunch of matrices on my calculator. I'll be able to type over them. So once my calculator has edit in the far right column and A highlighted, I'm going to hit enter. And that's going to take me to a screen that will allow me to enter the matrix. So next thing I'm going to do is hit enter. The first thing I see is the dimension of the matrix A. And matrix A is a 2 by 3 matrix. So what I'm going to need to type now is I'm going to need to type where my number 3 is. I'm going to type 2 and hit enter. Then my calculator will bump over to where the 4 is. I'll type 3 and hit enter. So the next thing is to type the dimension. Hitting enter each time you type a number. And now I'm just going to enter the matrix. And my calculator is set up perfectly. I see the matrix there. I'm just going to type the numbers in order. I'm going to go 1 and then enter, and then 2 and then enter, and then 3, enter, 4, enter, 5, enter, 6, enter. Have the matrix in on my calculator. Once you have the whole matrix in, you're going to hit the second key, and the key right next to the second key, which says mode, and the word above mode is quit, is really what I'm activating. So second and quit brings me back to the main screen. Let me clear out my main screen. So my matrix is in. If I want to check my matrix to make sure I have it entered right, just to check to make sure I haven't entered it wrong, I'm going to hit the second in matrix again. And again, the matrix is on the X inverse key. So second in matrix. And just to check a matrix, you want to have the names column highlighted and the name of the matrix that you're wanting to check. And I wanted to check matrix A. So I have the names highlighted and the A highlighted both. And I'm just going to hit enter. And what that's going to do is it's going to, on my main screen, it's going to write the name of the matrix all by itself without any indication of what's in the matrix. So that brings the A to the main screen. Hitting enter a second time is going to actually show me the matrix that I entered, and I see 1, 2, 3, 4, 5, 6, so I've entered that matrix perfectly. Let me do the same thing for matrix B, meaning enter it and then check to make sure I have it entered right. So let me go through it slowly but without writing down each step. So to enter matrix B, the first thing I do is hit the second key, then I hit the X inverse key, and that's going to give me the screen that allows me to enter a matrix. To enter a matrix, you use your right arrow and get the edit highlighted. In this instance, I want to enter B, so I use my down arrow to get B highlighted with the edit highlighted. So if I had B and edit highlighted at the same time, that will allow me to enter matrix B. Once I have the edit and the B highlighted, I hit enter. And that takes me to the screen where I can type in the matrix. First, I need to say its dimensions, so I'm going to type in 2 and 5, and that's going to create a matrix that has 2 rows and 5 columns. And then I just enter these one at a time, hitting enter each time. So 1, then enter, 2, then enter, 4, then enter, 5, 6, 3, 2, 4, 8, and 9. I believe I have the matrix in properly. Let me second and then mode or quit to get out of the matrix mode. Gets me back to the main screen where I checked matrix A. I can clear this out if I don't want to look at that, or if I can check matrix B by leaving this there. To check that I have matrix B right, I hit second, then the matrix X inverse key, get the names in the B highlighted at the same time, hit enter, and the first time you hit enter, it puts matrix B on the main screen without saying what the matrix is. And then if I hit enter a second time, it shows me the matrix that I put in B and says it looks just like my matrix B. I got that down properly. All right, so a matrix for our purposes is just a table that's going to have numbers. And it's going to be important to be able to enter matrices on our calculator. To enter a matrix on our calculator, we'd have to know the number of rows and the number of columns. And in section 8.2, we're going to create matrices from systems of equations, and those matrices are going to represent systems of equations, and we'll be able to use our calculator to solve the system. So if I was given the problem 1 or 2 and I was asked to solve, I'd probably use the elimination method. In problem 1, I'd probably make that y a negative 2y, add it together with the equation that has the positive 2y to get my matrix solved, or equation solved. In this section, we're going to be forced to do it using matrices. The first step to solve a system of equations using matrices is to create what I'll call as an initial or a first matrix. And it's real easy to do. And I'm going to put my matrix in matrix A on my calculator. So temporarily, I'm going to say matrix A equals, and what I'm going to do is just take the coefficients of the x's and make them in the first column. The first column of this matrix is going to have the numbers 8 and 2. The second column is going to have the coefficients of the y's. In the top row, the equation of the y had a negative 3 in front of it. In the bottom row, the y has a 1 in front of it. And then I'm going to write the numbers to the right of the equal sign in the third column. So I'm creating a 2 by 3 matrix right here. And eventually, I'm going to reduce this matrix by hand, doing the elimination method twice to get my answer. Before I do it by hand, I'm going to get the answer on my calculator. So I'm going to reduce the matrix using RREF on my calculator to obtain the answer. So for this problem 2, ultimately I'm going to need to do this by hand. But at first I can use my calculator. The steps to solve problem 2 using matrices on my calculator is to first enter matrix A. In my matrix A, that represents the equations 8x minus 3y equals negative 2, and 2x plus y equal to negative 4 look like that. So let me enter that matrix on my calculator as a 2 by 3 matrix. It has 2 rows and 3 columns. So real quickly I'm going to enter, go second, x inverse for matrix, arrow over to edit, have the A in the edit highlighted and hit enter, type 2, enter, 3, enter, 8, enter, negative 3, enter, negative 2, enter, 2, enter, 1, enter, negative 4, enter. Have the matrix in, I hit second and quit. Clear out this main screen. So first we enter the matrix. Second, we're going to do second and matrix again, which is the x inverse key, which we've done a couple times now. And then arrow over to math and down to RREF and not REF and hit enter. So let me do this second step. Second step, after I have the matrix in matrix A, I could check it if I want. Second matrix, enter, enter. There's the matrix A that I entered and it looks correct. Let me do the second step now. So first enter the matrix. I checked it to make sure it's right. Didn't really have to check it. Next step, second, then the x inverse key, which is the matrix key. Arrow over to math, and then I'm going to hit the down arrow a bunch of times, and eventually I'm going to come across RREF. Notice there's an REF and an RREF. You want to hit the RREF. So I hit second matrix, tab the math, arrow down to RREF. Now I'm going to hit enter. On my main screen, that's going to produce RREF. So right now, at first I entered the matrix, and then I did all this to get RREF on my screen. Third, we're going to get the name next to the parentheses in RREF. So ultimately, on this next step, my calculator is going to say RREF matrix A, and I'm going to close the parentheses. To do that, it's real easy. To do that, I hit second in matrix, which is that x inverse key. I stay under names, I have the names and the A highlighted, and I hit enter. So let me do that real quickly. I'm going to get my calculator. First I got matrix A in, I checked it. Then I finished this up. I have RREF on my main screen. Next to the RREF, I need the name of the matrix I want to reduce, which is matrix A. To do that, we hit the second and x inverse key. We have the names in A highlighted. We hit enter. And then I'm going to close out that parenthesis. So now my calculator has RREFA. And I'm going to hit enter one more time. And it's going to reduce matrix A. It's going to reduce matrix A to this matrix, 1, 0, negative 1, 0, 1, negative 2. This is as much as my calculator can do for me. I need to be able to interpret the answer for my problem from this matrix. Generally, the answers are the numbers in the right-hand column in alphabetical order. The x is going to be negative 1, the y is going to be negative 2. Let me explain to you why that's the case on this other screen, other sheet of paper. So my calculator took the matrix A and reduced it to a matrix that has the same solution as the initial matrix. And let me unwrap this matrix and make a system of equations. The first column represented the numbers in front of the x's. The second column in matrix A represented the number in front of the y's, and the last column represented the numbers in front of the z's. This top equation, in front of the equal sign, the top equation, if I make it back, it says 1 times x plus 0 times y equals negative 1. In the bottom equation, if I put an x next to the 0, a 1 next to the y, an equal sign to separate the sides, would say 0x plus 1y equal negative 2. That's doing exactly backwards. On the first step, I took a system of equations. I put the x's in the first column, the y's in the second column, the numbers without the equals to the right of the equal sign in the right column. Now I'm undoing that. I'm taking the matrix, taking it back into a system of equations, putting x's next to the numbers in the first column, y's next to the numbers in the second column, and an equal sign to separate the numbers in the last column. This first equation reduces, the 0y cancels, and it reduces to x equal to negative 1. In the second equation, the 0x cancels, and I get y equal to negative 2. And my answer to problem 2 is going to be x equal to negative 1, y equal to negative 2. Before I show you how to do that by hand, let me work another problem using our calculator. Let's do number 1 on our calculator. So for problem 1, to get the answer for that system of equations, I'm going to create the initial matrix. By hand, this is going to be nuisance. The work's a nuisance, but by my calculator, it's not a nuisance. So for problem 1, to get it solved on my calculator, I'm going to take the 6 and the 2 that were in front of the x's and make it my first column. The 2 and the implied negative 1 that's in front of the y's and make it my second column. And the 10 and the 5 that are to the right of the equal sign, make it my third column. I'm going to enter this in matrix A again, so I'm going to make this matrix A on my calculator. To make this matrix A on my calculator, I need to just enter it in A. Let me clear out my main screen. I'm going to go second, and then matrix. I'm going to arrow over twice to edit. I'm going to hit enter. This is a 2 by 3 matrix. It has 2 rows and 3 columns. So I'm going to type 2 enter, 3 enter. So 2 enter, 3 enter, and then type all the numbers. 6 enter, 2 enter, 10 enter, 2 enter, negative 1 enter, 5 enter. Once I have it entered, I hit second in mode, which I'm really worried about the quit. So second and quit. Let me check to make sure I entered it right by going second, and this is optional, you don't have to do this, but second matrix with the names highlighted, hit enter once, that gets A on the main screen, hit A again, peek to make sure this is right, 6, 2, 10, 2, negative 1, 5, it is right. Now I'm going to do the RREF, so I clear this out, I don't need to see that. I go second matrix, arrow over to math, either down or up. It's actually quicker to go up. Using the up or the down arrow, find RREF, hit enter. Next to the RREF, I need to have the matrix A, so I'm trying to get my calculator to have RREF A. To get the A, I just hit second and X inverse for the matrix, hit enter, close out my parentheses, there's RREF A. It's going to reduce the matrix. It's going to say this matrix reduces to 1, 0, 2, 0, 1, negative 1. The answers are x equal to 2, y equal to negative 1. If I need to, this top row represents 1x plus 0y equal to 2. I can put it back into the starting with the x's and y's and equal signs, which means x equal to 2. The bottom row says 0x plus 1y equals negative 1. The 0x cancels and I get y equal to negative 1. The answer to part A, question 1, is x equal 2, y equal to negative 1. So there's the answer to problem 1. Now we have to learn how to do them by hand. You're absolutely going to be required to do one matrix on the test by hand, and it's not going to be very pleasant. So I'm going to solve problem 2 by hand. And let me do it all on another sheet of paper because this takes a lot of room. So problem 2 started off with 8x minus 3y equals negative 2 and 2x plus 1y equals negative 4. First step, I already wrote the first step down. I'm going to create the initial matrix just by pulling off the numbers in front of the x's, the numbers in front of the y's, and the numbers to the right of the equal sign. A lot of times I instinctively separate the x, the y's, and the equal signs with a line. So you'll see a lot of my work having a line representing the equal sign. If a matrix represents a system of equations, it's nice to put a bar where the equal sign is. If it's just a random matrix that doesn't represent a system of equations, then the bar is not necessary. So we're going to get an initial matrix, a second matrix, and a final matrix. The final matrix is the one that will match our calculator. If on the test for the problem that says solve system of equations using matrices, actually it'll say solve the system of equations using row operations, check your answer using the RREF feature on our calculator. What I've showed you how to do now is to check your answer on your calculator using the RREF feature. I haven't showed you how to do it by hand. There's going to be one problem on the test that you need to do by hand. To solve a system of equations using matrices by hand, you have to get the initial matrix, a second matrix, and a final matrix, and you're going to have to do the elimination method twice. Step 1 is to eliminate the x, and in your second matrix, leave the top row unchanged and make a new bottom row. So I'm doing the elimination method. This is the x column. I want to eliminate the x's, so I want to get the same numbers in front of the x's with opposite signs. That 8 I'm not going to change. I'm going to make that 2 into a negative 8. What I'm going to do is take this whole entire bottom row, multiply every number in that bottom row by negative 4. So I'm going to leave the top row at 8, negative 3, and negative 2. And for the bottom row, I'm going to go negative 4 times 2 is negative 8. Just doing the elimination method without the letters. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. I'm going to add together 8 plus negative 8 is 0. Negative 3 plus negative 4 is negative 7. Negative 2 plus positive 16 is positive 14. This is a candidate for the new bottom row. Anytime I go to write my next matrix, I look at the results of my algebra, and if every number in a row that I create is divisible by the same number, I should probably divide that number by the same number. So I'm going to divide everything in this result by negative 7. When I do that, 0 divided by negative 7 is 0. Negative 7 divided by negative 7 is positive 1. 14 divided by negative 7 is negative 2. This is going to be my new bottom row for my second matrix. So my second matrix is going to have 0, 1, and negative 2. Done with the first step. I eliminated the x's in my second row. The x column was right here. I eliminated and got a 0 where the x was. I left the top row unchanged and made a new bottom row. I'm never going to look at this initial matrix again. When I go to do step 2, I'm only going to using the second matrix. So for step 2, I'm going to eliminate the y using the second matrix. And I'm going to leave the bottom row unchanged and I'm going to make a new top row. So I look at the y column and I want to eliminate the y's. I want to get a 0. And to get a 0, I have a -3 that I can pair up with a +3. I'm going to multiply the whole bottom row by 3. And when I do that, I'm going to leave the top row alone for a second. I'm going to leave it at 8, -3, and -2. I'm going to go 3 times 0 is 0. 3 times 1 is 3. 3 times -2 is -6. I'm going to combine these. And when I combine these, I'm going to get 8, 0, and -8. Since every one of these numbers is divisible by 8, I'm going to divide them by 8. I'm going to go 8 divided by 8, 0 divided by 8, -8 divided by 8. 8 divided by 8 is 1. 0 divided by 8 is 0. -8 divided by 8 is -1. I'm going to call this my new top row. I'm ready to write my final matrix. For my final matrix, the bottom row is going to be unchanged. So that bottom row of 0, 1, and -2 is going to be unchanged. My new top row is going to be 1, 0, and -1. That tells me the answer is -1 and -2. When I initially did this on my calculator, when I solved problem 2 on my calculator, I got that matrix, and I interpreted that to say x equal to -1, y equal to -2. In general, the answers are in order, are the numbers in the far right column, unless the rows to the left of this bar, the bottom row has all zeros, which I don't think comes up in this section. So we can safely say the answers are going to be the numbers in the right-hand column in that order. The answer to our problem 2 is x equal to -1, y equal to -2. Let me do problem 1 with you just to help you get through it. We just did problem 1 on our calculator, so we know what the answer is. On my calculator for problem 1, the answer is x equal to 2, y equal to -1. So we're going to try to get that for an answer. So for number 1, the answer is x equal to 2, y equal to -1. I need to get there by hand showing 3 separate matrices. So let me work through problem 1 with you. Really, really tedious to do. Way easier to do the elimination method like we did in the last section. But if you take Math 218, you might have to do matrices by hand. So step 1 is to create the initial matrix, or the first matrix. First and initial being probably interchangeable. So I'm going to have a first matrix, a second matrix, and a third and final matrix. And quite honestly, I know most of the matrices. The first matrix is a 6, 2, 2, -1, 10, 5. Putting a bar where the equal sign is just helps me with my math. The final matrix is that matrix. 1, 0, 2, 0, 1, -1, because that's what we got after we entered this matrix in. If I did second matrix and entered that, when I entered that matrix and did RREF, it reduced the first matrix to the final matrix. It doesn't show you the second matrix. So really, you only need to do the second matrix by hand, and you can kind of fudge and say, well, this is what the third matrix is. Let me do this by hand to get that second matrix. Step 1, on my second matrix, I'm going to leave the first row the same. So of the things that I need to show by hand, boy, there's not much there. I just need to get the second matrix, and the top row doesn't change. So for the second matrix, I'm going to eliminate the x. Create a new bottom row. Leave the top row unchanged. to eliminate the x's, I'm going to leave that a positive 6 and make that a negative 6, just doing the elimination method. So I'm going to multiply the bottom row by negative 3. I'm going to leave the top row at 6, 2, and 10. I like having that bar where the equal sign is, but you don't need it. Now for the bottom row, I'm going to go negative 3 times 2 and get negative 6. Negative 3 times negative 1 and get positive 3. Negative 3 times positive 5 and get negative 15. Add those together. 6 plus negative 6 is 0. 2 plus 3 is 5. 10 plus negative 15 is negative 5. Each one of those numbers is divisible by 5, so I'm going to divide them by 5 before I stick them in my matrix. When I divide all these by 5, 0 divided by 5 is 0. 5 divided by 5 is 1. Negative 5 divided by positive 5 is negative 1. This is my new bottom row for my second matrix. So each step, one row is changing, and one row is staying the same. My new bottom row is going to be 0, 1, and negative 1. Done with step 1. On to step 2. I'm going to eliminate the y's. And I'm going to create a new top row. I'm going to leave the bottom row unchanged. I'm only going to look at my second matrix. I won't look at the first matrix again. So that's going to take me down to this matrix. So how do I get there? I'm going to leave that a 2 and make that a negative 2 by multiplying by negative 2. So I'm going to leave the top row at 6, 2, and 10, and then go negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times negative 1 is positive 2. Add these together and get 6, 0, and 12. Each of these numbers is divisible by 6, so I'm going to divide it by 6 and get 1, 0, and 2. And this is going to be my top row now. The bottom row of 0, 1, and negative 1 stays unchanged. The top row becomes 1, 0, and 2. My calculator already knew what they should be. And my answer is going to be the numbers in the far right-hand column. My answer is going to be x equal to 2, y equal to negative 1. All right, so that's 1 and 2 with already 40 minutes into the video. Let's give 3 and 4 a shot. Let me do 3 with you and not do 4. So you can do 3 by yourself if you want, which would be wonderful if you pause the video and gave it a go. I'm going to do 3 with you. I'm going to get the first matrix that comes for free. It's going to be a 2 by 3 matrix, and the x column is 4 and 1. The y column is negative 3 and negative 5, and the z column is negative 2 and negative 9. Let me get the answer from my calculator, so I'm going to know what the last matrix, and the last matrix is the third matrix, which is kind of the answer matrix. I'm going to do that all on my calculator for now, then I'll back up and do it by hand. So on my calculator, first step, second and x inverse. Over to edit, and I'm going to enter in matrix A a 2 by 3 matrix. So I'm going to hit enter, 2, enter, 3, enter. Second and quit. Double check that I've entered it right by going second matrix, hitting names, and hitting enter. If you enter the matrix wrong, you can't get the right answer, so I just made sure I had the right matrix in. Now I'm going to do RREF, second matrix, arrow right to math. You can go down to get to RREF or up to get to RREF. It's a few less steps going up. Now I'm going to get the A next to it, so I want RREFA. And when I hit enter, it's going to give me the final matrix, so it's 1, 0, 1, 0, 1, 0, 1, 2. The reason the answers are x equal to 1, y equal to 2 is because this really means 1x plus 0y equals to 1. That simplifies to x equal to 1. This really simplifies to 0x plus 1y equal to 2, which simplifies to y equal to 2. So my answer is x equal to 1, y equal to 2. We need to go from our first matrix to our second matrix, and then from our second matrix to our final matrix. In my second matrix, the top row doesn't change. I get a new bottom row. So, step 1, eliminate the x. Leave top row alone. Make new bottom row. So I'm going to try to eliminate the x. I'm going to make a 4 and a negative 4 to eliminate my x's. I'm going to multiply the bottom row by negative 4. I'm going to leave the top row at 4, negative 3. I didn't put the bar in. I really kind of like that bar. Negative 2. Now I'm going to go negative 4 times 1 is negative 4. Negative 4 times negative 5 is positive 20. Negative 4 times negative 9 is positive 36. Combine. Negative 4 and 4 gives me a 0. Negative 3 and 20 gives me a positive 17. Negative 2 and 36 gives me a positive 34. All of these numbers are divisible by 17, so I'm going to divide by 17 and get 0, 1, and 2 for my bottom row. So into matrix 2, my bottom row is going to be 0, 1, and 2. For this step now, to get from the second matrix to the last matrix, I need to eliminate the y, and I'm going to leave the bottom on row unchanged and make a new top row. So to eliminate the y's, I need the same numbers with opposite sign in front of the y's. I'm going to multiply the bottom equation by 3 to do that. I'm going to leave the top 4, negative 3, negative 2. Then I'm going to go 3 times 0, which is 0. 3 times 1, which is 3. 3 times 2, which is 6. Add the rows together. 4 plus 0 is 4. The negative 3's cancel. Negative 2 and 6 is positive 4. All of those numbers are divisible by 4, so before entering them in the matrix, I'm going to divide them by 4. I'll write off to the right here because I'm kind of out of room. This 4 divided by 4 is 1. That 0 divided by 4 is 0. That 4 divided by 4 is 1. That's going to go into the top row of 1, 0, and 1. Now I've matched up because the bottom row, 0, 1, 2, comes from the matrix above it. The top row comes from here. I have my last matrix right. I read off my solutions and I'm done. I know that some of these problems have fraction answers. Let me do problem 6. I'll let you do problem 5. And for each one of these problems, the first matrix comes with no work, and I can get the last matrix on my calculator. Once I get a fraction answer, the work gets a little bit uglier, and I kind of have an extra step at the very end that I haven't got to yet, that we won't get to on the test because I won't make fraction answers on the test. So I'm going to enter this on my calculator in matrix A. I don't have to call it matrix A when I'm doing it by hand. So second matrix, arrow over to edit. It's a 2 by 3 matrix. Need to be in y equals. And let me check that matrix real quickly by checking under the names. So 4, 1, 11, 3, negative 5, 37 looks fine for me. Second second matrix, math, RREF. Second matrix, names, close the parentheses, enter, beautiful. My last matrix is going to be this. One, 0, 4, 0, 1, negative 5. My answer is going to be x equal to 4, y equal to negative 5. So I just need to get that second matrix to show up. And on my second matrix, the top row is going to remain. So the 4, 1, 11 hangs out. And I already know what the bottom row is going to be. It's going to be 0, 1, negative 5 if I do it right. I guess I could fudge the whole way and get an answer. So first step, eliminate the x. Don't change the top row. Make new bottom row. To eliminate the x's, I'm going to need 12s in front of the x's. One has to be positive, the other has to be negative. I'm going to multiply this row by negative 3 and this by positive 4 to get a negative 12 and positive 12 in front of my x's. This 37 bugs me, but I'll live with it. So for the top row, negative 3 times 4 is negative 12. Negative 3 times 1 is negative 3. Negative 3 times 11 is negative 33. Bottom row, 4 times 3 is 12. 4 times minus 5 is minus 20. 4 times 37, I'm afraid to do that, is 148. Combine. 12s cancel. Negative 20 and negative 3 is negative 23. Afraid to do negative 33 plus 148. Should get 115. Think all those numbers are divisible by 23. I'm going to divide by negative 23 just to match up with my calculator's work. First division, 0 divided by negative 23 is 0. Second division, negative 23 divided by negative 23 is 1. Last, 115 divided by negative 23 is negative 5. So this now is going to be my bottom row. So in my bottom row, I'm going to put 0, 1, and negative 5. So I eliminated the x's. I didn't change the top row. I made a new bottom row. Next step, eliminate the y's. Don't change the bottom row. That's why this bottom row is right there unchanged. That bottom row doesn't get changed. Make a new top. So I'm going to eliminate the y's. I'm going to multiply the bottom row by negative 1 to do that. So I'm going to leave the top for a second at 4, 1, and 11. Then go negative 1 times 0 is 0. Negative 1 times 1 is negative 1. Negative 1 times negative 5 is positive 5. Add these together and get 4, 0, and 16. Each of those numbers is divisible by 4. So I'm going to divide them by 4 and get 1, 0, and 4. And that's going to be my top row. So when we're doing this on a test, I'll need to see the elimination method done twice by hand. Oh, yeah. We have 3 more problems for this part of the video. Maybe we'll do 2. Let me do your number 7 with you. So pause the video. If you're ready to do number 7 by yourself, do it by yourself. If you're not, then watch me do it. I'm going to do problem 7. I'm going to get a first matrix from my calc by hand, the last matrix from my calculator, the answer from my calculator, and come up with a second matrix by hand. So I'm going to enter this in. So second matrix, edit. It's a 2 by 3 matrix. So 3, 2, 11, 2, negative 1, 5. Second quit. Let me make sure I have it in right just by checking. So there's 3, 2, 11, 2, negative 1, 5. Now I'll do my RREF. So go over to math, up to RREF, get the matrix A in there. My final matrix has a 3 and a 1 in the right-hand column. So my final matrix, or my answer matrix at that, is going to be 1, 0, 3, 0, 1, 1. My answer is going to be x equal to 3, y equal to 1 for your problem 7. So, first bit of work, try to get my second matrix. So I'm going to eliminate x. I'm going to leave the top the same and create a new bottom row. So for my second matrix, and I need to see every matrix on the test because you can do so much on your calculator, my second matrix is going to have a 3, 2, and 11 for the top row. The bottom row should be 0, 1, and 1. I'll better get that by hand, but I'm pretty sure I know what's going to be because that's the bottom row I'm going for. So to eliminate the x's, I'm going to get a 6 and a negative 6. I'm going to multiply the top row by 2 to get a 6 in front of that 3, the bottom row by negative 3 to get a negative 6, and that will cause the x's to cancel. So I'm going to go 2 times 3 is 6, 2 times 2 is 4, 2 times 11 is 22, negative 3 times negative 2 is negative 6, negative 3 times negative 1 is positive 3, negative 3 times 5 is negative 15. Add these together and get 0, 7, and 7. Divide by 7, divide by 7, divide by 7. That gives me 0, 1, and 1 for my bottom row. Done with my second matrix, on to my third matrix. For my third matrix, I'm going to eliminate the y. And bottom stays the same. Need a new top. So I'm going to multiply the bottom by negative 2 to eliminate the y. Temporarily, I'm going to leave the top at 3, 2, and 11. I'm going to go negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 1 is negative 2. Add these together and get 3, 0, and 9. Divide everything by 3. Divide by 3, divide by 3, divide by 3, and get 1, 0, and 3 for my new top. So you've got to show me the elimination method twice when you're doing these by hand on the test. All right, I'm voting for just one more problem each. And we have 9, 10, 11, and 12. If you feel the need to do more, you can do 11, or you can skip if you want to. And I'll do problem 9 as opposed to problem 10, just in case you're not completely getting it, then you can have the work in front of you that you need to see. If you can get problem 9, you can stop watching the video now and just do problem 9 and be done and move on to our second part of the video. So problem 9, my first matrix is going to be 4, negative 2, 7, 2, negative 5, negative 3. My last matrix, notice I'm getting a little bit lazy. I probably should call this my first or initial matrix. Should probably call this my third or my final or my last matrix. My last matrix I'll get using my calculator temporarily. So I'm going to enter second matrix, edit that 2 by 3 matrix. Do all the math that I need to do on my calculator. Oh, there it is, fraction answer. Let me make sure I entered that matrix right. So math, second matrix, enter. 4, negative 2, 7, 2, negative 5, negative 3. I entered it right, and I get horrible fractions or decimals. Let me get my calculator back to the answer. So I'm going to go second matrix, math, RREF, second matrix, names A, parentheses, enter, decimals. So I'm going to hit math, enter to get my fraction answer, and it's going to be 1, 0, 41 over 16, 0, 1, 13 over 8. The answer is going to be x equal to 41 over 16, y equals to 13 over 8. This is unpleasant, but we'll deal with it. So the first matrix isn't going to be so bad. It's getting the final matrix that might be kind of bad. I don't put fractions on the test, so it's not a huge deal here, but we should do it. So first step, eliminate the x's. Leave the top row the same. So when I go to do my second matrix, the top row is going to remain 4, negative 2, positive 7. I'm going to eliminate the x's by multiplying the bottom by negative 2. I'm going to write 4, negative 2, 7, and then negative 2 times 2 is negative 4. Negative 2 times negative 5 is positive 10. Negative 2 times negative 3 is positive 6. Combine, get a 0. Combine, get an 8. Combine, and get a 13. If I wanted to, I can divide all these by 8 and get the 0, 1, 13 over 8. But I don't want to work with fractions any more than I have to. I'm not going to divide just yet. I eventually need to match up with my calculator. When we have a fraction answer, we'll have an extra last step to do that we haven't got to yet. Done with my first step, on to my second step, and I'm actually going to get a third matrix before my final matrix when the answer is a fraction. And my third matrix, the bottom row doesn't change. It's going to be 0, 8, and 13. I get a new top row by eliminating the y's. To eliminate the y's, I'm going to make that into a negative 8 by multiplying by 4 so that my 8's will cancel. I'm going to go 4 times 4 is 16. 4 times negative 2 is negative 8. 4 times 7 is 28. I'm going to leave the 0, 8, and 13 alone. Add these together. 16 plus 0 is 16. Negative 8 plus 8 is 0. 28 and 13 is 41. I can write this as my top row, or I can make my top row look like this. And I'm going to make my top row look like this because I don't need to do any more work with this top row. Before putting this into the matrix, I'm going to divide all of these by 16. 16 divided by 16 is 1. 0 divided by 16 is 0. Any fraction with a 0 in the numerator is equal to 0. And 41 over 16 is what I need to have in that column. So I have now the top row matched up, the bottom row not quite matched up. I'm going to now do my division. Instead of doing the division right here by 8 to match up my bottom row, I'm holding off and doing my division now. Going from a third matrix to a fourth and final matrix, I'm going to divide each of these numbers by 8 and put those into my bottom row. So fraction answers, you get an extra step. This 0 divided by 8 is 0, which is that 0. This 8 divided by 8 was 1, which is that 1. 13 divided by 8 doesn't reduce, it's that. So now I successfully have reduced this matrix into the fraction answers. And again, you're not going to get a fraction matrix on your test. So let's pause the video. Take a good break before you do part 2 of this if you're not really feeling motivated, because it's much more tedious.